welcome to another video from Hegarty Maths. It's Mr. Hegarty here. It's the 32nd video in our maths revision list and it's on probability trees. Just to remind you how this works, I'm going to recap the topic briefly, not teach it from scratch, but recap. You take detailed notes and then what you do, pause the video, try all the exam questions that have come up on this topic, then play the video and mark your work. You can print out the notes from hegartymaths.com, the Secure a B C course within GCSE. Right, to start with, tree diagrams. Now, tree diagrams seem to come up every year. Once you get into the habit of them, they're fairly okay. And I'm going to introduce you to the idea with three basic examples and show you basically the styles that come up. Now, imagine there was a bag filled with 2 blue, 8 red and 2 yellow marbles. Decca picks a marble out of the bag, notes its colour and replaces it. She then picks another marble from the bag, draw a probability tree. So there are two events that happens. She takes a marble, she looks at it and puts it back, and she takes another one. So we're going to do a probability tree with two events happening, and at each stage 3 things could happen. So when you're drawing this, draw it nice and spread out like this. So either she gets a blue, or she gets a red, or she gets a yellow. Okay, on the first pick. So she gets a blue, or she gets a red, or she gets a yellow. Okay, a blue, a red, or a yellow. And the probability she gets a blue, well, in total she's got 2 and 8 and 2. There are 12 marbles. So the probability of blue is 2 out of 12. The probability of red is 8 out of 12, and the probability of yellow is 2 out of 12. Having picked one of these, she picks another one again. So if she picked a blue, she can pick another one again, and she either gets a blue, a red, or a yellow. Again, a blue, a red, or a yellow, and again a blue, a red, or a yellow. Okay, so I'm going to write these in. So that's blue, that's so the blue, red, yellow, blue, red, yellow, and blue, red, yellow, blue, red, yellow. Now, because she puts the marble back, imagine she took a blue out on the first go. She takes a blue out, she writes down it's a blue, and she puts it back. The number of blues nor the number of marbles in the bag change. So the probability of getting a blue, again, I'm going to write these all in the same colour, is 2 out of 12. The probability she got a blue, then she gets a red, well, it's 8 out of 12, and it's 2 out of 12. So it's 2 out of 12, 8 out of 12, and 2 out of 12. And the last one again is 2 out of 12, 8 out of 12, and 2 out of 12. Now, you can work out the probability of 2 blues, you can work out the probability of 2 reds, and you can work out the probability of 2 yellows. And what you do is you multiply the probabilities. So you're going to multiply this by this to get the probability of 2 blues. And when you multiply fractions, we're going to do 2 twelfths times 2 twelfths. You multiply tops and multiply bottoms to get 4 out of 144. This one here, 2 reds, well, you do 8 out of 12 multiplied by 8 out of 12, which is 64 out of 144. And last one, you're going to do 2 out of 12 times 2 out of 12 again, and you get 4 out of 144. Now, let's answer the questions that we could work out all of these different combinations, but most of the time you don't need to do that. These are the key ones to work out. So what's the probability of getting 2 reds? Well, 2 reds is this one. So it's simply 64 out of 144. We've done that. What about 2 blues? Well, it's this one. It's 4 out of 144. What about 2 yellows? Well, it's this one. It's 4 out of 144. Now, what's the probability of getting 2 different colours? Well, 2 ways of doing it. We could either get a blue and a red and work out this, or blue and a yellow and work out this, a red and a blue work out this, a red and a yellow work out this, a yellow and a blue work out this, and a yellow and a red work out this, and add them all up, which is going to take us ages. Or what we could do is we could simply do 1 subtract all of these added together. So 1 subtract 64 out of 144 plus 4 out of 144 plus 4 out of 144. Because either they're all the same or they're different. So because probabilities have to add to 1, if we do 1 take away they're all the same, it must give us the probability that they're all different. So what we can do is 1 take away, and we can say 64 out of 144 plus 4 out of 144 plus 4 out of 144. And we get ourselves, well, a half, but that would have been equal to 72 out of 144, okay, or a half. Right, next example. It looks identical, but there's one difference. Can you spot it? Well, this time, Decca does not put the marble back in the bag, okay? So when she takes out, let's say, if she took out a blue, she puts it away. She doesn't put it back in the bag. So the number of marbles in the bag and the color probabilities change. And this is the one that usually comes up in the exam. So let's draw this one. So there are 2 cases. So there are 2 things that happen, and 3 possible things that can happen. Either get a blue, a red, or a yellow, or having done that, get a blue, a red, or a yellow, a blue, a red, or a yellow, blue, a red, or a yellow. And we're going to fill it in. So this time, she either gets a blue. Now the probability of blue is, in total, there were 12 marbles, so it's 2 out of 12. The probability of a red is 8 out of 12. And the probability of a yellow is 2 out of 12. Now, then she either gets a blue, red, and yellow, blue, red, and yellow, or a blue, red, and yellow. Make sure you do them in the same order. Now, imagine going along this route. They took a blue. Imagine they took a blue, and they put it away. Decca put it away. There is now 1 less marble in the bag and 1 less blue. So the probability of a blue again, there's only 1 left, and it's out of 11. The reds did not change, so there are still 8 reds, but there are 11 marbles, and the yellows didn't change, so it's 2 out of 11. These must add up to 11 out of 11. Now imagine she didn't actually take out a blue, she took a red, so she took a red out. Now, the blues are still the same. There are 2 blues in the bag, so it's 2 out of 11. The reds, however, have gone down to 7, so it's 7 out of 11, and the yellows are 2 out of 11. Okay, what about if she didn't take out a blue or a red? In fact, she had taken out a yellow. So if she took out a yellow, the probability of another yellow is 1 out of 11 now. But the reds haven't changed, so it's still 8 out of 11, and the blues haven't changed, so it's 2 out of 11. Okay, all I'm going to do is, like before, I'm going to work out the probability of a blue, of a red, and of a yellow, because I can get everything else from that. So a blue is 2/12 multiplied by 1/11, which is 2 out of 132. The probability of red, well, it's 8 out of 12 multiplied by 7 out of 11, which is 56 out of 132. And the probability of yellow, well, it's 2/12 multiplied by 1/11, it's 2 out of 132. So we can fill in these. The probability of 2 reds, well, I've just worked that out, 56 out of 132. 2 blues, well, that's 2 out of 132. 2 yellows, well, again, that's 2 out of 132. And the probability that they are different, well, I could do 1 take away the probability that they're the same, i.e. 1 take away all of these added up. So 2 out of 132 plus 56 out of 132 plus 2 out of 132. 2 add 2 is 4, add this is 60 out of 132, and I know that 1 take away 60 out of 132, 1 take away 60 out of 132 is equal to 6/11, so I can just write 6/11s there. Okay, last type of example. Imagine they gave you the probability trees with decimals. The same thing applies. Upon each branch, looking back here, remember, maybe I didn't say this, these always must add up to 12 out of 12. These must add up to 12 out of 12. These add up to 12 out of 12. These add up to 12 out of 12. And in the case where they change, would these add up to 12 out of 12, whereas these add up to 11 out of 11. That adds up to 11 out of 11, and that adds up to 11 out of 11. So here, the probabilities on each split must add up to 1. So this is about Liverpool's chances of winning or not winning their next two matches. The chances for each match are independent. It says the probability they win the first match is 0.7. What's the probability they don't win? Well, it must be 0.3 for them to add up to 1. The probability they win the second match is 0.9, so the probability they don't win is 0.1. And we can fill in here again 0.9 and 0.1 for the second match, because this was the first match and this was the second match outcome. Okay, what's the probability of a win-win? Well, you do 0.7 multiplied by 0.9. So you can do 0.7 multiplied by 0.9 and you get yourself 0.63. 0.63. What's the probability of losing both games? Well, sorry, not of losing both games, of not winning, I should have said. I should have said here, of not winning. I should change this. Not winning both games. Well, it would be 0.3 multiplied by 0.1. So we would do not win would be equal to 0.3 multiplied by 0.1. 0.3 multiplied by 0.1 is equal to 0.03. What's the probability of winning one of the games? Well, the probability of winning one of the games would be either they could win this one and then they had to lose this one, so it would be 0.7 multiplied by 0.1, which is 0.07, or it would be not win the first one and then win the second, so 0.3 multiplied by 0.9, which is 0.27, and you would add these up. So it would be 0.07 plus 0.27, which is equal to 0.34. You can check that on your calculator. I should have written here the probability of winning both was 0.63, and the probability of not winning both games was 0.03. Okay, that's it for the examples. Time for you to pause the video, try the questions. After each one I show you, 5 seconds I'll go through. Here's the first one. Okay, Hannah's going to play a match of badminton and one match of tennis. The probability she'll win in badminton is 9 out of 10. The probability she'll win in tennis is 2 out of 5. Complete the diagram. So the probability she wins is 9 out of 10. So the probability she doesn't win must be 1 out of 10, because they must add up to 10 out of 10. Next one, the probability she wins tennis is 2 out of 5. So the probability she doesn't win is 3 out of 5, because both of these must add up to 5 out of 5. And we can complete it in this section. The probability she wins is 2 out of 5. The probability she doesn't win the tennis is 3 out of 5, because both of these, again, must add up to 5 out of 5. Then it asks us what's the probability she wins both. So that's the win-win case. So we do 9/10 multiplied by 2/5. With fractions, we multiply the top 18, we multiply the bottoms 50. We could write 18 out of 50 and we're done. Next question. Pause the video. I'll go through in 5 seconds. Okay, so Wendy goes to a fun fair. She has got one go at Hoopla. She's got one go at Coconut Shy. The probability she wins Hoopla is 0.4. The probability she wins Coconut Shy is 0.3. Complete the diagram. So she wins on Hoopla is 0.4. So the probability she doesn't win must be 0.6, because these have to add up to 1. Okay, and then we go to Coconut Shy. The probability she wins is 0.3, so the probability she loses is 0.7, and you can complete that over here as well, because these obviously must add up to 1. So this and this must add up to 1. and this must add up to 1. Then it says, what's the probability she wins Hoopla and wins Coconut Shy? So we're looking for a win-win. It's 0.4 multiplied by 0.3. 0.4 multiplied by 0.3 is a non-calculated paper. So what we could do is 4 multiplied by 3 we know is 12. So 0.4 multiplied by 3 must be 1.2. So 0.4 multiplied by 0.3 is 0.12. So 0.12. Next question. Pause. I'll go through in 5 seconds. Okay, so Sally has a bag of 9 sweets in total. There are 3 orange, there are 4 strawberry, and there are 2 lemon. She takes 2 out at random and eats them, so that means she's not putting them back, obviously. Work out the probability the 2 sweets are not the same flavour. So we better draw a tree diagram for this. So our tree diagram should be, give yourself plenty of space to do it, otherwise it will look messy and not work out for you. Okay, so what we're going to do is we're going to say the first one is either an orange, a strawberry, or a lemon, an orange, a strawberry, or a lemon, an orange, a strawberry, or a lemon, an orange, a strawberry, or a lemon. Now the probability of orange is 3 out of 9, the probability of strawberry is 4 out of 9, the probability of lemon is 2 out of 9. Remember they have to add to 9 out of 9, they do. Okay, then we're going to go to this one, the probability of an orange. If you took an orange, there's now only 2 left, and there's 1 less sweet in the bag. The strawberries haven't, if you took an orange, the strawberries haven't changed, so it's still 4, but it's out of 8. And if you took an orange, the lemons haven't changed, so it's still 2, but it's out of 8. These add to 8 out of 8. The next one, if you took a strawberry, the strawberries have gone down by 1, and the sweets in total have gone down by 1. The oranges haven't changed, they're still 3 out of 8, and the lemons are still 2 out of 8. These again add to 8 out of 8. Lastly, if you took a lemon, the probability of another lemon, well, there's 1 less lemon and it's out of 8, but the strawberries haven't changed, so it's 4 out of 8, and the oranges haven't changed, so it's 3 out of 8. And again, they add to 8 out of 8. I told you a little trick with these. It's always best to work out the probability of orange, orange, strawberry, strawberry, lemon, lemon. It saves you a lot of time. So orange, orange is 3/9 multiplied by 2/8, which is equal to 6 out of 72. Strawberry, strawberry is 4/9 multiplied by 3/8, which is 12 out of 72. And lemon, lemon is 2/9 multiplied by 1/8, which is 2 out of 72. Now, the probability that they're the same are these added. So the probability that they are the same is the sum of all these. So 6 add 2 is 8, add 12 is 20 out of 72. So the probability that they are different is 1 subtract 20 out of 72, which is 72 out of 72, take away 20 out of 72, which is clearly 50 out of 72. Oh, sorry, 52 out of 72. Okay, because 1 is 72 out of 72. 72 take away 20 is 52 out of 72. That's our answer. Next question. Pause the video. I'll go through in 5 seconds. Okay, there are 20 in the biscuit tin, there are 12 plain, there are 5 chocolate, there are 3 ginger. They take 2 at random, Caroline, so she doesn't replace them, she eats them. Work out the probability they're not the same. It's very like the last question. So, time for a tree diagram. Plain, chocolate, ginger. Plain, chocolate, ginger. Plain, chocolate, ginger. Plain, chocolate, ginger. And we'll write that as well. Plain, chocolate, ginger. Plain, chocolate, ginger. Plain, chocolate, ginger. Plain, chocolate, ginger. If she takes a plain, it's 12 out of 20. Chocolate, 5 out of 20. Ginger, 3 out of 20. They add to 20 out of 20, so we know we've done it right. Now, imagine she took a plain. There's now one left plane. There's one less plane here. Let me just make that smaller. There's one less plane, and there's one less biscuit, so 11 out of 19. I'm just going to work out chocolate. There's 4 out of 19, and I'm just going to work out this one. If she took a ginger, there's now 2 out of 19. I can do plain, I could do chocolate, or ginger. So for plain, it's 12 out of 20 multiplied by 11 out of 19. So we can do, 12 multiplied by 11 is 132, and 20 multiplied by 19 is a calculator paper. So 20 multiplied by 19 is equal to 380. So this one is 5 multiplied by 4, which is going to be 20, again out of 380. And this one here is going to be 3 multiplied by 2, which is 6 out of 380. So the probability that they're the same is if you add these up. So we're going to add up 132 plus 20 plus 380, which is equal to, not plus 380, 132 plus 20 plus 6, and we're going to get 158. So it's 158 out of 380. The probability that they're different is 1 take away 158 out of 380. And you've got your calculator for this, so you can do 1 take away 158 out of 380, and we get 111 out of 190. So we get 111 out of 190, and we're done. Next question, pause the video, try it. Non-calculated this time. Okay, exactly the same idea. There's different sandwiches, 4 egg ones, 5 cheese ones, and 2 ham ones. So in total, we need to know how much we've got in total. 4 add 5 is 9, add 2 is 11. Takes 2 at random. What's the probability that they're different? So it's exactly the same idea as we've done previously. Let's draw a nice picture so we can see everything. It's a little bit smaller here. Okay, so they can either get an egg, a cheese, or a ham, egg, cheese, or ham, egg, cheese, or ham, egg, cheese, or ham. Probability of an egg is 4 out of 11. Probability of cheese is 5 out of 11. Probability of ham is 2 out of 11. They add to 11 out of 11. Having taken an egg, there's one left sandwich left, and there's one left egg sandwich left, and one left sandwich, so it's 3 out of 10. This one here, cheese, well, it must be 4 out of 10. And this one here, ham, well, it must be 1 out of 10. So we can work out the probability of an egg, of a cheese, and of a ham. The probability of egg is 4 times 3, which is 12, over 11 times 10, which is 110. Probability of cheese, 5 times 4, which is 20, out of 11 times 10, which is 110. And the probability of ham, 2 multiplied by 1 is 2 over 110. So the probability that they're the same, we add up these. 12 over 20 is 32, add 2 is 34 out of 110. So the probability that they're different is 1 take away 34 out of 110. Now 1 is 110 at 10 out of 110, take away 34 out of 110, and 110 take away 34 is going to equal 76 out of 110. So that's 76 out of 110. Okay, next one. Pause the video, try it. I'll go through in 10 seconds. Okay, so this one is slightly more complicated. It says there are 7 tiles, and Jim takes a random tile. He doesn't replace it, then he takes another. Calculate the probability that Jim takes one with number 1 on it. Well, what are the options you can take on the first tile? Let's draw a probability diagram. You can either take a 1, a 2, or a 3. And then afterwards you can take a 1, a 2, or a 3, a 1, a 2, or a 3, a 1, a 2, or a 3. So here are the options. Again, just 1, a 2, or a 3, a 1, a 2, or a 3, a 1, a 2, or a 3, a 1, a 2, or a 3. The probability of 1 is 2 out of a possible 1, 2, 3, 4, 5, 6, Sorry, 1, 2, 3, 4, 5, 6, 7. There are 7 in total. So it's going to be 2 out of 7. The probability of getting a 2 is 1, 2, 3 out of 7. And the probability of getting a 3 is 2 out of 7. If you did take a 1, there is now 1 left, so there's now 1 out of 6. If we're just going to fill in this one here. If you took a 2, the probability of another 2 is 2 out of 6. And if you took a 3, the probability of another 3 is going to be 1 out of 6. Now it says calculate the probability that both have a number 1. So the probability of a 1 and a 1 is 2/7 multiplied by 1/6. 2 multiplied by 1 is 2. 7 multiplied by 6 is 42. Calculate the probability that the number on the second tile that Jim takes is greater than the number on the first. So let's look at when this is true. Imagine he took a 1. If he got another 1, would that be greater? No. But 2 would be and 3 would be. So they're 2 options. If on the other hand he took a 2, getting a 1 would not be greater, getting a 2 would not be greater, but getting a 3 would be greater. And if he took a 3, taking a 1 would not be greater, a 2 would not be greater, a 3 would not be greater. So there are 1, 2, 3 options that this could happen. The first one would be this option multiplied by this option. So we're going to have to fill in the whole table here. If he took a 1, the probability of a 2 is still 2 out of 6, and the probability of a 3 is still 2 out of 6. If he took a 2, the probability of a 3, well, there are still 2 left, but it's out of 6. So here are the options. It's going to be this one multiplied by this, add this one multiplied by this, add this one multiplied by this. So I might clear up the diagram a little bit here. Write that a little bit smaller up here. So it's going to be 2/7 multiplied by 2/6, which is going to be 4 out of 42. And it's going to be 2/7 multiplied by 2/6, which is 4 out of 42. Or it's going to be 3/7 multiplied by 2/6, which is 6 out of 42. And you're going to add these together. 4 and 4 and 8, add 6 is 14 out of 42. Next one, pause the video, have a go. Okay, it says the probability that John buys fruit is 0.7. In the same supermarket, he independently buys veg, and the probability he buys veg is 0.4. Work out the probability that John buys fruit or vegetables or both. So let's just do a branch for each decision. So let's say the fruit first. Either he gets fruit or not fruit, or he gets veg or not veg, or veg or not veg. Now the probability he gets fruit is 0.7, so the probability he doesn't is 0.3. The probability he gets veg is 0.4, so the probability of not is 0.6, so we can write 0.4, 0.6 here. Now we're looking for the probability he buys fruit, or he buys vegetables, or he buys both. So this one we want, fruit and veg is a possible option, so it's 0.7 multiplied by 0.4. The probability he buys fruit and not veg is a possibility, so it's 0.7 multiplied by 0.6. The probability he buys not fruit but veg is 0.3 multiplied by 0.4. And the probability of not fruit, not veg, well, that's the only one we don't want, so we don't care about that. So this one is going to be 0.28, this one's going to be 0.42, and this one's going to be 0.12. I'm going to add these up. 12 and 42 is 54, add 20 is equal to 74, add 8 is equal to 82. So this is going to be 0.82. Anyway, that's it for this video. Hope you found that useful. Thanks for watching.